Okay, let's go back to our example. And now rather than just have 3 points that I kind of specified as logical locations, let's actually bring up a data set and represent that data set up on the map. So I'm going to read in a data set that's from Open Data. It's a website, you can take a look at it. It's about companies that kind of support open data. So I'm going to call it od.companies for open data companies, and that's my variable. I'm going to read the CSV file specified by the URL. So I just went out to the web to read this file and load it in. And now I can take a look at the structure of od.companies. It's a lot of information. So we have the company's name ID, the company name, the URL of the company. So there's the first name of the company, for example. Year founded, the city and the state, so that's going to be pretty useful. The country, zip code, a whole bunch of other things. And then different things about the actual company. So that's pretty much what we have for that. And then we have to clean it up, though. Why do we have to clean it up? Well, it's got some stuff that's a bunch of NAs. And by looking at it, one of the things I could tell is if there's no city, then it's not going to really work in putting it in a map. So we're going to get rid of the companies that don't have a listed city. Oops, let's run the whole line. So here, so we got rid of all the companies. We'll take a look at the size of this. $496 companies now. How many do we have before? Find it. 532. So we got rid of about 40 different companies that didn't have this data associated with it. Now I have to fix up some abbreviations. So the first thing is we have to do change a state from a factor to character. That was this line of code. And then what we want to do is we're going to remove Washington, D.C. We don't treat that as a state in our data set, so for now, to simplify it, this code just says we're going to keep all of the rows if the state does not equal DC. This line says if it's Kansas, the abbreviation KA should really be KS, because we have some, that's how they abbreviated it, and if not, just use what the original state abbreviation was. So we updated that. Now what we're going to do is create a city-state based on the city and the state, and we're using the paste command to combine them together. So if we look at od.companies, Philadelphia, PA, and if we looked at city, Philadelphia, and if we looked at state, PA. We kind of just paste them together as you would expect. Now the next line of code I'm not going to run because it would call geocode for about 500 times for each city-state. And that takes about, I don't know, 5 minutes or so, and I think it would be pretty boring for you to kind of stare at the screen doing that. You can certainly do this line at home, but I did that before. It's kind of like the cooking show, it's already done. So we're going to just store the geocode into the data frame. If you're curious what that looks like, it's pretty simple. It's just the 476 observations of latitude and longitude. So it's the locations specified by the city and the state. Now we can use that information. Now that we have the geocode, the X and the Y location, we can use that in our jam point, just like we did before. Wow, it's not what we really expected. What is going on here? You can see there's 1 point over here. So most of them look pretty good. There are like a bunch of in California over here. There's actually a couple in Colorado, some in Texas, a whole bunch on the East Coast, some up near Seattle it looks like. But there's one thing over here. So that's most likely just a bad data point. we're going to see what that point is. If I take a look at bad, it looks good, but for some reason it thinks there's a city, Vilnius, Alabama, in the US with this zip code, and when we did that, so either that doesn't exist, or something. So that's a bogus data point. So in order to make this a realistic, we're going to just remove that data point. So it's the same logic that we've been using before to clean up this data set. Using this if condition, we're going to keep only the ones that are there. And now let's redraw this map. That looks better. So we have the points where we expect to see the points. Now we can kind of show the points by the size of the number of employees. So if we take a look at number of employees, we can see it has 9 levels. But if we see it, it's sorted kind of not in the right location. Like it's not sorted that you expect. Maybe it's easier if I show this. See, here's how it's sorted. The first group is 1 to 10, then it's 1,000 to 5,000, and then it's over here. So what you want to do is you want to kind of reorder this so that the order is 1 to 10, 11 to 50, and so on. So with this line of code, I've now created my company sizes that is ordered like that. So now it'll come out as we expect in kind of a continuous range like we wanted to. And we can show that. And here we go. So we have the different sizes. Let's make it a little bigger so you can get a feel for what we're looking at. So small companies and large companies, different locations in the US. So obviously lots of small and large companies. That's Washington, D.C., that's Philadelphia, that's New York, that's Boston, Chicago, Seattle, and you can see a couple of small companies just throughout. So we've kind of, I think I'm going to stop there, but what we've done is we've taken the data and we've read in a data set. We've looked at the location of a company to city and state. Then we looked at the size of the company. We could obviously have shown any other data point we wanted. And based on that, we were able to show points on the map.